Okay, students, today we're going to start a new chapter, Chapter 9. And if you're looking in your book with me on page 412, we're going to see that it's called Systems of Linear Equations. And so this idea then is we're going to work with two or more equations that have the same variables. And we're going to see that there's a lot of different ways for us to solve a system of linear equations. And so that's what we're going to look at this week. Now, let's look at some definitions to get started. And so here we go. We see two or more equations in the same variable form a system of equations. And most of the time for us in Algebra 1, it's going to be two linear equations. A solution of a system of two linear equations in two variables is the ordered pair that satisfies both equations. Now today we're going to concentrate on the graphing method. And you're going to find out, personally, this is my favorite method because it's pretty quick. We're going to find out tomorrow when we start using the other methods, we've got a lot of jumbling numbers. And so it takes a little bit of time to get the job done. But here, if we're graphing, it seems a lot simpler. So if you remember right before break, we spent some time reviewing graphing, and this was why, because I knew this idea of graphing systems of equations was coming. So we're going to look at number 1 here. And if you look there, what form are those lines in? Yeah, those lines are in standard form. And so we learned back in Chapter 8 that to graph equations in standard form, that I use my x and y intercepts. We graph by x and y intercepts. So I'm going to take the first line. I like to color code things. I'm going to make it the blue line. And how do we solve? Do you remember how to solve to find those x and y intercepts? Yeah, good job. It was the 0 thing. So this is the blue line. And if I go in and I want to solve for x, remember we make y 0. And if I make y 0, then x equals 6. Now we do the opposite if we are solving for y. If we're solving for y, then we're going to make x 0. And then if we solve, we get y equals 6. And so now I can graph both of those points, my x-intercept and my y-intercept on my graph. So I'm using, I said I was using blue, so let me get my blue pen. 1, 2, 3, 4, 5, 6. Big, fat, juicy dot on my x-intercept at 6. And then same thing on my y-intercept. And now we just connect the dots. Now, when we're graphing systems of equations, it really helps to use a grid, okay, and not just making your own, how sometimes Mrs. Burton does that, because it's real important to see their point of intersection, because that's how we're going to find the ordered pair that satisfies both. Now, let's go ahead and let's take the second equation. We'll make it the green equation, and let's find our x and y intercept. So remember, if we're solving for x, we make y 0, so x equals 2. And then we do the reverse. If we're solving for y, we make x 0, and that's negative 2. Okay, so let's graph our 2 points, our x-intercept and our y-intercept. My x-intercept is at positive 2. My y-intercept is on the y-axis at negative 2. And if I go to connect those dots, there we go. Now, the ordered pair that satisfies both equations is where those 2 lines intersect. Now, where do they intersect? Well, 1, 2, 3, 4. I have to go right 4, so that's my x-coordinate. And then we have to go up 2. So their point of intersection, the ordered pair that satisfies both equations, is 4, 2. All right, let's try another one. Let's look at number 2. What form of the line are these equations? Yes, Mrs. Burton gave you a slope-intercept form. And we know how to graph lines in slope-intercept form. So let's go ahead and look at the first one. We'll make it the blue line. And if I look there, well, we know my y-intercept is 2. And slope is a positive understood 1. So remember, we plot B first. So I'm going to put a big, fat, juicy dot on the y-axis at 2. And my slope is positive 1, so we're going to rise 1, right 1. And if I go ahead and take those and connect the dots, there's my line right there. Okay, let's go ahead now and let's graph our second line. I'll make it the red line. And here, when I look, well, my y-intercept is -1 and my slope is positive 2. Remember, the slope is what's in front of x and the y-intercept is the constant term on the end. So, -1 on the y-axis is my y-intercept, big, fat, juicy dot. And this time our slope is 2, so we're going to go up 2, right 1. And if I go ahead and I connect the dots there, I'll make this one dotted, okay? Connect the dots. Well, if you notice, wow, they go right beside each other. What kind of lines are those? What did we learn they were back in chapter 8? Yes, those are parallel lines. Now, if those are parallel lines, there's no point of intersection, okay? And if there's no point of intersection, okay, then there's no ordered pair that satisfies both equations. So when we get parallel lines, our answer is going to be no solution. And again, parallel lines never intersect. And so that means I have no solution. There's no one point, no one ordered pair that's going to satisfy both of those equations. Now, let's look at my number 3, and let's figure out how we want to graph these. And again, I said use any method. So if I'm looking at the first equation, we'll make it the black one this time, and I look there, well, if I was going to do the 0 thing, if I was going to solve by x and y intercepts, I would actually get fractions. And I know most of you don't really like that. So let's just go ahead and rearrange the furniture and put this in slope-intercept form. Remember, y equals mx plus b. So in order to do that, I've got to subtract x to the other side. So we've got 2y equals -x plus 5. And now I have to divide everything by 2 because I've got to get y alone. So y equals negative, and that's going to be what? -1/2 x plus 5 over 2. Now, that means that my y-intercept is 5 over 2. Oh, Mrs. Burton, it's a fraction. What do I do? Well, that's really 2.5, so we can work with that. And then my slope is -1/2. So, for my y-intercept then, if it's at -2.5, I'm going to go to the y-axis and put a big, fat, juicy dot halfway between 2 and 3. My slope is -1/2, so we're going to go down 1, right 2, and notice, and now I just connect the dots. So if I go to connect the dots, here is line number 1. Now, if I go to graph the second one, well, that's going to be pretty easy and standard form to figure out my x and y intercepts. So let's solve for x. So we'll make y 0, and that's going to give me -1. And then if I switch that, and now let's solve for my y-intercept. So remember, we make x 0, and that's going to be +1. Okay, remember? All right, so now let's graph them. So my x-intercept is -1. My y-intercept is +1. And then we're going to take the blue line and connect the dots. And when I connect the dots, where do they intersect? Remember that point of intersection is my ordered pair that satisfies both. So if you look, we're going to have to go over 1, right 1, so that makes my x +1. And then we're going to have to go up 2 to get their point of intersection. So the answer, the ordered pair that satisfies both equations, is 1, 2. All right, now let's go ahead and look at number 4. If I want you to graph both lines there. Well, the first line's kind of easy, if you notice. Okay, we've already got it in slope-intercept form. I'm going to make it purple. We've already got it in slope-intercept form, so that means b equals 4, and m's whatever in front of slope, or whatever in front of x, so my slope is 2/5. So we're going to go to positive 4 and put a big fat juicy dot. My slope is 2/5 up to right 5. 1, 2, 3, 4, 5. Now, I have to draw this freehand because I use purple, so let's try it. Oh, not too bad. All right, so there's my first line. Now, when I look at the second line, okay, we'll make it blue. Let's make it yellow. If I make it yellow, now, which way do I want to graph those? Well, we can put it in slope-intercept form, or we can do the x and y intercepts. You notice we're going to get fractions. So let's go ahead and put it in slope-intercept. It might be easier. So if I'm going to do that, then that means that I'm going to have to get y alone. So we're going to have to add 2x to the other side. So we've got 5y equals 2x minus 5. And once again, y isn't alone, so I need to divide everything by 5. So y equals 2/5 x. Negative 5 divided by 5 is negative 1. So when I go to graph this one then, my y-intercept is negative 1, and the slope is 2/5. Ah, some of you see it already. Good job. Okay, but let's go ahead and graph. If my y-intercept is at negative 1, and we're going to apply our slope 2/5 up to right 5. And if I go ahead and graph those, what happens? Yes, I get parallel lines again. How many of you noticed that the slope of my purple line was 2/5 and the slope of my yellow line was 2/5? What do we know about the slopes of parallel lines? They are the same. So once we realize we have parallel lines, remember, parallel lines never intersect. There's no point of intersection. So our answer here, once again, would be no solution. Good job. All right, I think we have one more to look at. And let's go to our last set of equations. Okay, here's number 5. Now, once again, I gave you 2 equations. I gave you one in slope-intercept form. All right, I gave you one in slope-intercept form, and the other one is in standard form. All right, so let's graph the first one. Here I know that my y-intercept is 3, and my slope is negative 1. So positive 3 on the y-axis, we go up to 3. But my slope's negative this time, so we're going to go fall 1, right 1. And so there's my line. So let's go ahead and connect the dots. And when I go to connect the dots, there's my line. Now, let's see. Let's go ahead and do our second line. I'll go down here. And because that's in standard form, let's just go ahead and solve and graph by using our x and y intercepts. And so if we make x 0, then y equals 3. And if you look there, if we make y 0, then x equals 3. So let's go ahead and graph that. Now, if you notice, my x-intercept is 3, 0, so it's right there. And my y is 3, 0, and it's right there. What do you notice is going to happen? I'm going to do it in purple. It'll be easier to see. When I go to connect those dots, what happens? Wow, the second line graphed exactly on top of the first line. When you graph the equations in the same coordinate plane, you see that the graphs coincide, okay? One right on top of the other. The equations are equivalent. And again, how many points intersect? Well, when you look there, all of the points intersect. Every point on the line intersects. And so when you graph and you get the exact same line like we did here in number 5, all points are common, all points intersect, and so our answer should be infinitely many. Okay? Infinitely many solutions, because every point on those two lines coincide. All right, now, if you need some help, they've got a very nice gray box on page 414 to kind of help you with the rules of the game. So if you need some help tonight, look there. I want you to try some graphs tonight, and then tomorrow we'll look at everything again together. Good job.